Okay, today we're going to start looking at 3.7, perfecting my quads. So basically we're looking today at solving for your x-intercepts using a variety of methods. So we've already done factoring, we've used the quadratic formula, even graphing should be familiar. The only new one would be taking the square roots. So we're going to start with that to make sure we understand the concept. So solving by square roots, the idea here is we want to isolate the quantity being squared. So maybe like, hey, if we have something in parentheses squared, we're going to isolate that. Or if you've got, an x squared, that is also something that you want to isolate. Then we're going to square root both sides. Don't forget, when you take the square root of something, remember there's two answers. So like, for example, the square root of 9, there is both a positive and a negative 3 that will get you back to 9, because positive 3 squared is 9. But also a negative times a negative is a positive, so negative 3 times negative 3 is also 9. And then if necessary, we're going to simplify. So looking at this first example, we want to isolate this x squared, right? We want to get x squared all alone. So how do you get rid of that fraction out front? There's a couple different ways you can do it. I think a lot of people like to just divide by 2/3, which is definitely works, and you can type that in your calculator. I personally like to multiply by the opposite fractions, the reciprocal. So 2/3 times 3/2 on both sides. Then we get 24 times 3 divided by 2 gives me x squared equals 36. So now we take the square root of both sides. So the square root and the x squared cancel out, so we're just left with x. And then when you take the square root of 36, you probably recognize that one just as 6. But it's both a positive and a negative 6. Hi, this next one. We are trying to isolate this x minus 2 squared. So we've got a plus 5 at the end, so we want to get rid of that. So we're going to subtract 5 from both sides. So we get 16 equals x minus 2 squared. So now we want to go ahead and get rid of the square root. So we're going to take the square root of both sides. So when we take the square root, we get both a positive and a negative. The square root of 16 is 4. And we're left with x minus 2 on this side because the squared and the square root cancel. So now to get x all alone, we're going to add 2. I usually do like to put that 2 up front because I think you're used to seeing it that way, equals x. So here, be careful, there's really two different answers. You have 2 plus 4 equals 6, and 2 minus 4 equals a negative 2. So x equals both a 6 and a negative 2 is your two different answers. So that's why I think it's good to put it at the beginning, because I think you then remember to do both the plus and the minus. It is not, be careful, like if I add it at the end, it's not plus or minus 6. Notice these numbers do end up being a little different. Okay, this next one, we're trying to isolate x squared. So if you just think about that as like 7x plus 10, and don't even worry about the squared equals 74, we'd start by adding 10 to both sides. So we get 7x squared equals 84. Then we divide both sides by 7. And we get x squared equals 12. So same thing, take the square root of both sides, and you get x equals plus or minus the square root of 12. So now we just got to take the square root of 12 and see if that simplifies. In this case, the square root of 12 is not an integer, but I can break it down to 4 and 3, and then 4 down to 2 and 2. So because there's a pair of 2's and then the leftover 3, that's the same as 2 square roots of 3. So x equals plus or minus 2 square roots of 3. Okay. Next one. Start off in a similar manner. We're trying to get the x minus 1 squared alone. So we're going to subtract 1 from both sides. So we get 4 times x minus 1 squared equals 8. Divide both sides by 4. Notice now I have that quantity that is squared all alone. So x minus 1 squared alone equals 2. So now I can take the square root of both sides. The square root and squared cancel, so I'm left with x minus 1 equals plus or minus the square root of 2. So we're going to add 1 to both sides. Once again, I like to put that 1 out front, so 1 plus or minus the square root of 2, because I think that's how you're used to seeing it with the quadratic formula. But really what that means is you have two different answers, 1 plus the square root of 2 and 1 minus the square root of 2. Remember, you can't combine those because you can think of them as like not like terms. Okay. Carlos, Clarita, there's a few people here that I should have taken out. So it's just Clarita, Tia, and their best friend Zach are all discussing their favorite solving methods of the quadratic equations of the form ax squared plus bx plus c. Here are their different strategies. Zach likes to graph. Okay, so Zach is going to graph everything and then find the solutions. So he's going to be looking for the x-intercepts on his graph. Clarita likes to write the equation in factored form and then use the factors to find the solution. So she's going to factor. And last but not least, but Tia, I also like to use the quadratic formula to find the solutions. Quadratic formula. Okay, so we're going to go through and we're going to do two different examples where we look at how to solve this using the three different methods. Okay, so this first one, we have x squared minus 2x minus 15. So since Zach likes to graph, I'm going to go ahead and switch to my camera real quick, and we're going to go ahead and graph it. So we've got y equals, we've got x squared minus, I forgot the equation, sorry, 2x minus 15. I'm just going to go ahead and look at the graph because I think that will be enough to see where it crosses the x-axis. So notice here over on the left it crosses at -1, 2, 3, so -3. And on the right it crosses 1, 2, 3, 4, 5. If you have a hard time seeing those points, you can always look at your second graph, which will give you a table of values, and you're looking for when y is 0. So notice that it is at 5 and at -3. Okay. In this case, since we just care about where it crosses the x-axis, I'm actually going to just plot those 2 points. It does end up going down a lot, so it's off the graph. But here we can see your two x-intercepts, right, are these 2 points right here. So x would equal both a -3, and a +5. Okay, now let's go ahead and go to Clarita's method, which she said is factoring. So we're looking for what multiplies to -15 and adds to -2. The factors here are -5 and a +3. And in this case, we can use the shortcut. So we can do x minus 5, and then x plus 3 equals 0. And remember, using the zero product property, it means that, hey, either this x minus 5 equals 0 or x plus 3 equals 0. So x equals, as you add 5 to both sides, x equals 5. As you subtract 3 from both sides, x equals a -3. So notice we got the same two x-intercepts. Tia's strategy of using the quadratic formula, remember you got to start with what a, b, and c are. So a is 1, b is a -2, and c is a -15. So we're going to plug it into our equation. So -b, the opposite of b, is a +2, plus or minus the square root of b squared, which is -2 squared, minus 4 times a is 1 times c is -15, all over 2 times a is 1. So we get 2 plus or minus the square root. If I go ahead and type in that -2 squared minus 4 times 1 times a -15, I get the square root of 64 divided by 2. The square root of 64 we know is 8, so we get 2 plus or minus 8 divided by 2. So I usually do this two different ways. I do 2 plus 8 divided by 2, so I get 10 divided by 2 is 5. And then I do 2 minus 8 divided by 2, so I get a -6 divided by 2 is a -3. So once again, we get the same answers. X equals a +5 and a -3. So it doesn't matter which format we do it in, we end up with the same thing. Okay, same thing again, we got another one, and we're going to do the same one. So we're going to look at the graph for Zach, we're going to factor for Clarita, and we're going to use the quadratic formula for Tia. Okay, so new equation, let's go ahead and see what we can do. So First one, if we're going to go ahead and graph, let's pull out our graphing calculator. So in this case, we have 2x squared plus 3x plus 1. And let's look at the graph. So notice this one, it looks like it crosses at -1, and then it's a little harder to tell there, but it's about halfway between. So this one maybe graphing isn't as good a method, because it's a little bit harder to tell, but it looks like it's at -1 and then like partway between here, right? So we get something, sorry, having a little difficulty here. There we go. It looks something like this, right? So if I had to take a guess, I think -1 is definitely it, and then maybe like -1/2. But this one we're not quite as sure about. Okay, so maybe these factoring the quadratic formula will help us to tell it in particular. So let's go ahead and factor. We're going to take 1 times 2, and we get 2. So we're looking for what multiplies to 2 and adds to 3, which is 2 and 1. So we get 2x squared plus 2x plus x plus 1 equals 0. And we're going to factor by the GCF. So this has a GCF of 2, this has a GCF of 1. As we divide both those terms by 2x, we're left with a 2x out front, and then an x plus 1. As we divide both those by 1, we're left with x plus 1 as well, equals 0. So as I write in my 2 sets of parentheses, I get 2x plus 1 as one factor and x plus 1 as the other. So we got two different solutions. 2x plus 1 equals 0, and x plus 1 equals 0. As you solve this for x, you subtract 1, so we get 2x equals -1. Divide by 2, so x equals -1/2. So it did end up being -1/2. We were able to tell, right? And then this one, we can subtract 1 from both sides, x equals -1. Okay, let's use the quadratic formula. A equals 2, b equals 3, c equals 1. X equals -b, so a -3 plus or minus the square root of b squared, 3 squared, minus 4 times a, which is 1, times c, which is 1. All divided by 2 times a, which is 2. We get -3 plus or minus the square root of 9 minus 4 is the square root of, oh, I forgot that's a 2, my bad, sorry, 2 for a. I plugged in the wrong number. Everyone see that? Did you correct that? 4 times 2 times 1. So 9 minus 8 is just 1 all over 4. So we get -3 plus or minus 1 divided by 4. So there's two different answers here, right? One is a -3 plus 1 divided by 4. So we get -2 divided by 4, which is -1/2. The other one is -3 minus 1 divided by 4. So we get -4 divided by 4, which is a -1. So x equals -1/2 and a -1. So notice we get the same answer no matter what method we do. So now we got some different ones. So remember, you can solve quadratics by taking the square root, graphing, factoring, or the quadratic formula. For the record, when you're doing the graphing, factoring, or the quadratic formula, you always need to have it equal to 0. The square root is not the case, but just be aware of that. So like as we look at this first one, I would probably set it equal to 0, so maybe I'd subtract the 4x and the 45. So we get x squared minus 4x minus 45 equals 0. There are lots of things. I could say, okay, let's graph it and look at the graph, right? I could say, let's factor it. Let's see if it factors. I could use the quadratic formula. The only one that doesn't work here is the square root, right? Because it's not just a quantity being squared. Notice how we have both an x squared and an x. You need just something squared in the equation. The variable should not happen twice. I'm going to try to factor here, because if I can factor, that's actually, I think, factoring or graphing are probably the two easiest methods. So we're looking for what multiplies to -45 and adds to -4. So I've got a -9 and a +5. Okay, so that does factor. X minus 9, x plus 5 equals 0. So now I just set both of these factors equal to 0 and solve for x. So x equals a +9 when I add it to the other side, and x equals a -5 when I subtract to the other side. On your homework, it usually asks for it just with a comma between. So like, hey, your answer here would just be 9, -5. You're welcome to switch the order. -5, 9 is the same. Okay, this next one, I'll be honest, maybe it factors, but the reality is I look at that and I'm like, well, I don't want to factor that. That looks kind of hard to factor, right? So we could try graphing, right? The only problem with graphing is like, let's take a look. Let's just try graphing for a minute. So let's see if it comes out nicely or not. If you do like that, -8 x squared, what was the next part, sorry, minus 18x. Oops, sorry about that. I think it was -9. Let me just double check that though. Yep. So as you look at that graph, if it ends up crossing like at specific numbers, that's great. But notice here how it's like between -1 and -2 and between 0 and -1. Like, it doesn't look like it's nice numbers. So that probably means two things. One, that it doesn't factor, and then also that graphing's not probably the most accurate method. So here, let's use the quadratic formula, because that is the method that's always works. It doesn't matter what the situation. A equals -8, B equals -18, C equals -9. So x equals the opposite of b, or -b. So it's going to be a positive 18 then. Plus or minus the square root of b squared, so -18 squared. Minus 4 times a is -8 times c is -9. All divided by 2 times a -8. 18 plus or minus the square root. Now let's figure out what that is underneath the parentheses. So that -18 squared minus 4 times a -8 times a -9 gives me 36 all over -16. So I get 18 plus or minus 6, because the square root of 36 is 6, divided by 16. So there's two different answers here. 18 plus 6 divided by -16. 18 minus 6 divided by -16. 18 plus 6 is 24 divided by -16. So that does become 3 over, if you divide both by 8, 3 over -2. And if I do 18 minus 6, that's 12 over a -16. So that's 3 over a -4. So it looks like that one would have factored if we wanted in the end, but notice how it's hard for us to tell those numbers. So it really is like these x-intercepts were -0.75 and -1.5, so they're hard for us to tell. Okay, let's go to the next one. This next one, I would say, okay, hey, notice how we just have one x in our equation. It is being squared. So this one, maybe like the square root, would be the easiest method. Okay, let's subtract 6 from both sides. X minus 4 squared equals 25. Now take the square root of both sides. X minus 4, because the square root and squared cancel, equal plus or minus the square root of 25 is 5. Add 4 to both sides. So we get x equals 4 plus or minus 5. So let's see what those chances are. 4 plus 5 is 9. 4 minus 5 is a -1. So this one, your x equals a positive 9 and a -1. You can also write that the other way and do -1 and then positive 9. Same result. Okay. Last but not least, I notice I cannot use the square root here. I can subtract 5 from both sides. So I get 2x squared minus x minus 5 equals 0. So my options here are factoring. I could use the quadratic formula, or I could graph. It's up to you what you'd like to do here. Remember with graphing though, if you get things that are like decimals or fractions, not always the best method. So maybe I just decided to go with the safe option and I use the quadratic formula. For the record, factoring does work here as well. So a is equal to 2, b is equal to -1, c is equal to -5. x equals the opposite of b, so positive 1 plus or minus the square root of negative 1 squared minus 4 times 2 times a negative 5, all divided by 2 times 2. So we get 1 plus or minus the square root of, let's see what that is, negative 1 squared minus 4 times 2 times a negative 5 is square root of 41. Okay, I actually lied here. The factoring would not have worked out for us. Okay, all divided by 2 times 2 is 4. So the only question is, does the square root of 41 simplify? And as far as I can tell, when you divide 41 by different numbers, you don't get anything even, so it's prime. So that would actually be your final answers. There's no further way to break it down. All right, it's your turn to go ahead and practice kind of taking the square root of quadratics, and then the second part, like the set part of your homework, is going to be you can choose your different method, but you have a variety of different quadratics to solve.